All right, letters D and E, they don't have any calculations with them. They're just counting. Estimate the area of the figure. Okay, and we're going to assume that each one of these boxes is one square unit. All we have to do is count, and then we're going to add together partial units that seem like they fit together. So let's just count the squares that are completely uh, enclosed or completely a part of the figure. Here's one. Let's just keep going. So there's one. Here's another one, two. Let's see. We've got three here, four right here. I can put a box in. Five up here, six. This one's really close, so I'm just going to count it because we're just estimating anyway. All right, that's it. Oh, wait. I forgot one. Seven. And now we have to ask ourselves, can I essentially make boxes out of any more of these? Okay, so I put this one and this one together. I can say, yeah, that's about this one and this one together take up about another space. So I'm going to put one here. That's going to be close. So that covers these two. Let's see. Maybe the way I'm going to show that is by just dragging this so it's like half. So it kind of fills in both spots there. And let's see. Down here, I noticed that this one has a curve out and this one has a curve in. It looks like they kind of fit together. So I'm going to do the same thing up here with these two. This is basically a box right here. All right, let's see. This one and this one seem to kind of go together, so I'm going to count those ones as one down here at the bottom. All right, so I didn't touch this one yet, and as I look, let me just count how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one looks like it's going to go together when I consider. So none of these pieces are actually left. Let's see. This one probably goes together with the remaining pieces of the rest of these. Like this up here, this up here, this and this all together with this to make one more box. So I'm just going to include one more box down here. So at this point, I'm just kind of counting up partial boxes to see how I could fill them. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes looks about right. Let's see if we got the estimated area of the figure that the book got approximately 11 square units. Okay. And remember, the way I did that was I counted the full square units first. And then I counted the square units that obviously went together. Like there were some that looked like they sort of complemented each other to basically make a full box. And then in the end, I just looked at, I said, okay, is there enough left over to make maybe one more box? So 11 square units would be a right answer. I don't think in this one I would have accepted 10 or 12 because I don't think you could justify those two. However, in the next one, this one's tough. There's probably a little bit of justification that you can do. Um, let's see if we can figure this one out. So once again, I'm just going to start by drawing a box that's about the size of one of these. And let's draw that box and count how many complete ones we have. So that's 1, 2, 4. Uh, let's see. We'll do two more down here. This one might be cut off just a little bit, but we'll count it. Okay. So all of these partial ones on the sides. It looks like my next full one is going to be up here. And then this one basically looks full. It might be missing a little bit of the corner, but that's okay. It's almost a full unit. We're just estimating anyway. We're going to do our best to estimate. Okay, and then we're going to do the same thing here. These are basically full boxes here. Up a little. There we go. And then straight above that, I basically have two more. And then even two more right above that. Okay. And now we're starting to get to the point where I've counted all of my boxes. Let's see, these two. I wonder if I just count this. There's a partial one here that's almost full. I think I'm just going to count that as a full one. Then the only other one that's really full is this one way up here. Okay, now I'm going to just do on either side. We're going to say that these two together make about 1. So I'm going to put 1 right here. That's going to count for those two. In fact, what I'm going to do is I'm just going to drag this over the river so we can see that that one's already taken care of. Now, this one and this part here looks like it will go together with this part here to make a full one. So I'm going to just go ahead and put one over here. And I'm not going to count anything over here, although this one and this one look like they'll make a full one. So I'm going to put one over here. And we're just going to say that these two are accounted for in these two, okay? If I were drawing on this, I might just put X's over these two pieces to let myself know I used those already. This piece and this piece look like they go together. So I'm going to just put 1 over this piece, and that'll count for this little piece too. Let's see. This piece and this piece might go together. So I'm going to do that, put 1 here. It counts for this piece. These two pieces basically go together, so I'm going to count 1 for those two. Okay, now there's one up here that we skipped right in the corner. I'm going to say that that piece is going to go together with this piece down here and make a box. So I'm going to cover over that one. And now I'm left with everything on the bottom, just this row and the very bottom row. So these two very roughly go together. It's going to be a little more than a box. I'm just going to keep that in mind. But I'm going to put these two together. And then it looks like what I have on the top matches what's on the bottom. So this matches under here. This one matches what's underneath. The next one matches what's underneath. Maybe a little less than a box, but that's okay because over there I had a little more than a box. So I'm going to keep going. This one matches this one down here. One right here matches down here, and then the last one matches what's below it. Now I would say that on the bottom here I'm overestimating, like I don't think those were really enough to fill up a whole box. Maybe I would take one of these boxes away to make up for that. I think I'm just going to leave them all here. Let's look at what we're estimating. So in the question, it says the school committee wants to put gravel on its new running path. Estimate the amount of gravel they must buy if every square meter of path requires 40 kilograms of gravel. Honestly, I think, well, it kind of depends on your situation. Maybe you do want to have too little gravel and then buy more so that you don't have a bunch left over. Might be nice to have too much gravel and then you can just do the whole thing and you'll have some extra. But anyway, let's count how many of these we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, 50, 60, 70, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. I have 33 boxes. I can decide to take one back if I want to make it 32 because I kind of overestimated the running path on the bottom. So it takes 40 kilograms of gravel per square meter. We have 33 square meters. So I'm going to do 33 times 40. That gives me 1,320 kilograms of gravel. Let's just see if I was in the range that the book said. 1,200 to 1,400 kilograms of gravel. If I would have taken back 1 square, I would have been down to 1,280, which is still in the range. So that is how you do that. For these two problems, for the estimating problems, you just count. Count whole squares first, and then put obviously fitting together squares together next, and then see if you have any left over to make an additional square, or take away a square if you feel like you took a little too much. All right, and that's how you do these problems. So for next time, you should be able to work the problem set associated with lesson 57.